This video is going to be going over April 19th assignment, which is our first day of STAAR Review. So this is going to be STAAR Review 1, which is going over functions, scientific notations, and real numbers. All right, so we'll start off with question 1. It says the diameter of Mars at its equator is 4,221 miles. The scientists usually use scientific notation to represent very large numbers and very small numbers. How would Mars' diameter be written in scientific notation? All right, so we have standard notation here, and we want scientific notation in the long run. All right, so what we do is we're going to go ahead and write out our number. We have 4,221 miles, okay? So, and we have our decimal point here. In scientific notation, we have our first digit decimal, and then whatever's remaining times 10 to some type of power. If it's a big number, our numbers are going to be positive, so big. Our numbers are positive. If it's a small number, it's going to be negative. When we're talking big, we're talking about larger than 10, okay? And we're talking about small, we're talking smaller than, or less than 1, my bad, less than 1. All right, so we can see that this number is larger than 10. So what we're going to do is we're going to get this decimal point right in between. So we only have one digit here, okay? So we know our first digit is going to be 4. Let's see, we're going to move it over 1. All right, here, let me do it a different color. All right, we're going to move our decimal over 1, 2, 3 spaces. So we have our decimal here now, okay? So we know all these numbers are going to go here. So we have 2, 2, 1. And we said we went over 1, 2, 3 times. So it's times 10 to the third power, which is answer choice A. A is the correct answer for number 1. Let's go to number 2 real quick. Mercury's average distance from the sun is 3.6 times 10 to the 7th power miles. How would this distance be represented in standard form? So we're going to do the exact opposite that we did the last time, okay? So we have the number, let's just worry about 3.6. So we have 3.6, all right? So we see that we have a positive 10. So that means we're going to move our decimal place to the right 7 spots, okay? So we have our decimal here. We're going to move it over 7 times. So we would go over 1, 2, 3, 4, 5, 6, 7. So our new decimal is going to be right here. So we fill in all these spots with zeros. We have 0 here. We have 1, 2, 3, 4, 5, 6 zeros, okay? So now our new number is 36 million, which is answer choice D. D is the right answer for number 2. Now let's look over at question number 3. Number 3 says a unit price of a 1 ounce of Jif creamy peanut butter is $0.094. Okay, how would this value be written in scientific notation? So we see that we have this number 0.094. We can see that this number is less than 1. Okay, so that means when we write it in our scientific notation, we're going to do 10 times a negative number. We're going to have a negative number this time, all right? Because we can see that we're going to be moving the decimal this way, okay? So let's see how many spots we need to go over. Remember, we want our decimal to be between our first number and our second number, okay? So we're going to move it over 1 space, 2 spaces, okay? So now we have 9 here, 0.4, and we went over 1 space, 2 spaces to the right. So when we want to go backwards, we go to the left. So it's 10 to the negative 2nd power, okay? So like I said, when we want to write this back out, so here's our scientific notation form. When we write back out the standard, we go to the left 1, 2 spaces, and we're back to where we started, okay? So it's negative. Answer choice D is the correct answer for number 3. Let's skip down to question number 8 real quick. All right, number 8 says, determine if the following is a function or not a function. Okay, so it gave us a graph. Now we have to use so number 8 says, determine if the following is a function or not a function. So when we're given a graph, we have to use this test called the vertical line test. So that means anywhere on this graph, we can draw a vertical line going from up and down. Remember, vertical is straight up and down. Horizontal is this way. We're doing the vertical line test. okay? So not this. We want this one right here, up and down, okay? So that means we can draw a vertical line anywhere on this graph, and if it hits the line only one time, then it is a function. If it hits it twice, 1, 2, it becomes not a function, okay? So if we draw a line here, we see that the graph hits the vertical line here and here. It hits it twice, so that means we're not a function. Let's check it one more time. If we draw our line here, we have a hit here and we have a hit here. That means we have 2 hits on one vertical line. So again, we have a not a function. So our answer on this one is not a function, all right? Now let's skip down to question number 10. Number 10, we're doing the same thing. We're determining if it's a function or not a function. So we're going to use the vertical line test again. So let's draw a vertical line here. When we draw a vertical line here, we see it only hits one time here, so it looks like it's going to be a function. Now let's draw it again over here. Only hits it here once. If we draw one here, it only hits once. If we draw one here, it only hits once. So every single time I drew a vertical line, our graph only hit the line once in each spot, okay? So that means this time we have a function, all right? So number 10 is a function. Let's move on to question 11. 11 says, determine the following is a function or not a function. So when things are a function and not a function, okay, when we're talking about just a function, every single x value here needs to be different. If we have a repeating x value, that means we have not a function, okay? Because every x value has only one y value, okay? All right. So we see that we have -9, we have 0, 1, and 3. We have no repeating x values, so that means we have a function, okay? Now let's say this 0 was a 9, a -9, then it would be not a function, okay? But for this problem, we have no repeating x values. We have 9, we have 0, we have 1, and -3, which means they're all different, so we have a function, okay? Now let's look on to number 12. We're doing the same thing. Let's look at all of our x values. We have -1, 4, -7, and then look, we have 2 -1s. We have a -1 here, and we have a -1 here. Since we have a repeating x value, we know it's not a function, okay? So number 12 is not a function. Number 13, determine if the following is, again, a function or not a function. When we're given maps, think about it as this is people, and this is a bus stop. You can only get off at one bus stop at a time, right? That's the only way it's possible. You cannot get off at 2 bus stops at one time, all right? So we see that every x value only goes to one y value, one bus stop. Each person, the 5 goes to only one bus stop. The 6 only goes to one bus stop, okay? Every x value has their own y value, okay? So 13 is a function. Number 14, determining if it's a function or not a function. We see here 1 goes to 4, so this person gets off at 1 bus stop. That's okay. This guy gets off at 1 bus stop, which is okay. Now this guy is getting off at 2 bus stops. This is not okay, so that means not a function. We have 1 x value going to 2 y values. If you think about it, if we draw it out in a t-chart, we have 1, 2, 5, 4, then we have 6 and 9, and then 6 and 4. See how we have 2 of the same x values right here? If we have 2 of these same x values, it's not a function, okay? Let's move on. Number 15, determine if it's a function or not a function. Again, we're looking at the x values. We're seeing if we have any repeating x values. And if we look at this, we have 1, 5, 6. None of them are repeating. 15 is a function, all right? Moving on to 16, determining if it's a function or not a function. Looking at x values again. Do we have any repeating ones? 4, 3, 2? Nope, no repeating x values, so again, we have a function, all right? Let's look at 17. 17, which of the given values of n would make this relation a function? So we're looking at something where it's going to make a function. Every x value has only one x value only has one y value, okay? So let's see. If we put 6 right here, we see that we have negative 10, 8, 9, 4, 6, and 12. Every single x value has their own y. We don't have any repeating x values, so 6 might be an answer. Let's put in 8 here. If we erase this and put 8, we see that we have 8 here, and now we have 8 again. We have repeating x values, so B cannot be our answer. Let's put in negative 10. We put negative 10 here. We see negative 10's also here. So we have negative 10 going to 2 and negative 10 also going to 5. So negative 10 can't be an answer. And 9, we have 9 right here as well. So if we put 9 here, we have 9 going to 3 and 9 going to 5, which is not okay. Okay. We're looking at just the x values. If we have repeating x values like 9 and 9, 10 and 10, 8 and 8, that's not okay. If we have all different ones, if we put 6 here, all of them are different, which means it's okay. So 17 is answer choice A. All right, let's look at question number 22 real quick. Number 22 says determine if the following is a function or not a function. All right, so again, here's our x values, here's our y values. We want every x value to be its own thing, okay? So the easiest thing is if it's in a map, just write it in a t-chart real quick. So we have x and y. Let's make our t-chart. So we have 3 going to 2, and we have 3 going to 3. So 3, 2, 3, 3. Negative 2 is going to 0, and then 0 is going to negative 1. All right, so let's look at this. We see that we have a repeating x value right here. We have 3 and 3. We have 3 going to 2 and 3 going to 3. So we have one person getting off at 2 different bus stops at the same time. That's not possible. 22 is not a function. All right. Let's go down to question 24. 24 says determine if the following is a function or not a function. So we have a graph. When we're given a graph, we're going to use the vertical line test. So we can draw a vertical line anywhere. If it passes through the graph once, that means we have a function. And by drawing these 2 lines right here, these 2 vertical lines, we see this graph only passes these vertical lines one time here and one time here. So that means we have another function here. All right. I think we're going to wrap up the video with that one. We're going to go over real numbers on a different video. So we're going to go ahead and just skip those. So we're going to end the video here. That was the video for April 12th, our STAAR review day 1. So if you need to complete the redo assignment for that day, please go ahead and work on that.